In this video, we're going to look at an exam question on proof by contradiction. So this topic is quite difficult because there's no one way of doing a question and every question is a little bit different. So what we do is we assume for a contradiction, the opposite of the statement is true. So here we're going to assume that there is a greatest rational number. And then if we disprove this assumption, then that means that the original statement has to be true because it's either one or the other. So let's go about disproving this assumption somehow. So let's say let x be the greatest rational number. So a rational number is in the form a over b, where a and b are integers in their simplest form. That's how you define a rational number. So that's just a fancy way of saying that a and b can be any whole number as long as a over b is in its simplest form. For example, 7 over 31 are both integers in their simplest form, or it can even be a whole number like 12 over 3, if that makes sense, because that goes down to 4. Now that we've established that this is the greatest, so we also have to let that be the greatest rational number. That means that there shouldn't be a rational number that's larger than it, if that makes sense. So I'm just going to finish writing this out. By the way, sorry my voice sounds weird. I think I have a blocked nose. How can we prove that this isn't the largest possible rational number? Well, if we add 1 to it, and I'll show you another trick. When you add a whole number to a fraction, you can actually change the whole number so that it matches the denominator of the fraction. So 1, you can write that out as b over b, because b divided by b is just equal to 1. Now that we've written it in this format, we can add the numerators together. A plus b is, well, just a plus b all over b. What we now have is, well, a plus b itself would be an integer, and b itself would be an integer. Now, what do we call an integer divided by an integer? It's a rational number. But what we said before is that a over b is the largest rational number. However, adding 1 onto it gives you another rational number. So that means that this isn't the greatest rational number because we've just found one that's even larger. So your final statement would be, this disproves the assumption. So the original statement must hold true. If you wanted to sound fancy, you could say this contradiction disproves the assumption, so the original conjecture must hold true, but yeah, no point in writing that. This is everything you need to do for this question. Be sure to leave a like if the video did help and subscribe. I'd appreciate it a lot. Thanks for watching.
I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.